Hey, this is FixReef, and today we have an Apex display module that arrived in this condition. There is no cable attached to it, although cable is included separately. And the problem is that it does not turn on. This was clearly a prior repair attempt because the cable is missing. But the problem is a fairly new issue to me, that this resistor is missing as well. And I don't think that the resistor missing was a part of the prior repair attempt. This was likely one of the earlier signs of the problem when the user realized that this needs to be fixed. So my theory is that this resistor, you can kind of see that there is a little bit of, I'm not sure if this is burn marks over here or just some signs of flux being applied to it to solder. But if this resistor came off violently, like it looks like it did, it's usually not the resistor that's causing trouble, but something else. I traced the signal that this resistor is handling, and it appears to be coming straight from the pin of the USB connector or AquaBus, which carries on those two pins, it carries 12 volts, fairly high. So it goes into this resistor, then across this resistor, and goes straight into this screen module that's kind of attached at the top here. So the big question is, if we were to replace the resistor, will it come on, or we have a problem with the screen? Because if the problem is with the screen, there is no really good reason to repair this unit. The screens are impossible to get given the age of this unit, and it's just not worth it, even if these screens were available. So first, what I'm going to do is I'm going to see if there is a short, because this is a positive 12 volts with a fairly high current coming through. So if there is a short of the screen that caused the resistor to blow up, then we need to know about it. If there is no short, and it's just the resistor that came off, then we can just attempt to replace the resistor and see if it works. First, I'm going to use my multimeter to make sure that I actually have. Okay, so looks like there is a damage on the. There you go. There's a damage on this pin, so we'll have to repair this if we end up repairing the unit. But so there is a direct link to the left side of the resistor, and I am not feeling anything on the right side of the resistor. Now the right side of the resistor is connected, I believe, to one of the pins over here. Let me figure out which one it is. I want to say it's the second one, the way I looked at it. Yep, it's the second pin from the right on the screen. All right, so if we attempt to measure if there is a direct short, there is no direct short. Let's see what kind of resistance we get on those pins. Obviously nothing here. Should be direct short. I don't see a short across this. That's a good sign. Let's attempt to replace this resistor and see if it works. Now, some of you asked, what is the value of this resistor? It turns out that the value is 143 ohms. There is an identical resistor over on this side of the board that has the same exact value over here. So the same, if your resistor is missing, look in the upper right corner and you will find a resistor that's of identical value here. All right, let's clean this up and see if we can replace it with something of a similar value at least. Okay, so this is the condition of the pad. It does look like that resistor blew up because it's not, I don't think it's just the problem with the soldering job that was done previously on it. So I don't think that that's the case. So what I'm going to do is I'm just going to apply a little bit more solder here to kind of clean up the pads nicely with the heat. Of course, the heat is going to do some additional damage to the surface of the board, but that's not particularly important. Not now, anyhow. Okay, now we're going to take all of that back and do some more cleaning. Looks pretty good to me. Let's clean up the area, too much flux everywhere. Let's especially on a whiteboard, you're going to see a lot of it. All right, now that this is gone, let's assess the damage. And it's not looking particularly good. I'm not sure if this is going to be repairable. There was definitely a short. You can see that this via is all dark, so that got some heat damage. There is some surface damage to the board as well. Again, not critical if the short is gone, but I don't think that the short is gone. And this resistor here is always missing. It's never installed. So, well, let's add the resistor and see what happens. New fresh solder, and I don't have the exact value resistor, but I do have something very close at 150 ohm resistance. So I'm just going to use that. It's a little risky because the original resistor has the less than 1% tolerance. So let's just hope that this one is going to work. Again, I don't have a lot of hope for this board right now because of the damage. I suspect that I almost never do I see resistors just blowing up. They always blow up because there is something else. Okay. Resistors in place. Now let's take a look at what's going on with this. There's also quite a bit of damage. This was definitely a prior repair attempt damage, because you can see, well, or maybe not. If the short occurred and it all took all of the solder away with it, maybe it wasn't the prior repair attempt. Maybe it was all relevant to the short. It's impossible for me to tell right now because I got the unit this way. Yeah, looks like wires sticking out here, so it came off with a physical force likely. Do some more cleanup. Lots of crud inside. But I see nice fresh solder in there, so I think we're going to be in a pretty good shape once all of this is restored. Let's clean up the crud that we got out and we'll do some more soldering. Okay, it's looking better already. It's not going to be the end of the world if we can attach it to the spins, but I think we have a chance. There was definitely a short that caused all of this. Hopefully the short was just between the AquaBus pins, power pins anyway. Then, if that's the case, then we can likely repair everything. Okay. Okay. I think that this is going to be good enough for now anyway. Okay. Now, I'm going to attach a test wire just to see how things are going to work. So let's add the positive, and let's just say that the brown wire is going to be negative. Okay. Now I'm going to just use my, now that we have the test wires attached, I'm just going to use my bench power supply and test this this display. It's consuming about 60, 70 milliamps. I can't see anything on the screen, but the screen is lit. You can't really see much, but the screen is definitely lit. All right, now I'm going to attempt to connect the actual wire. Here's the wire that came with it. Let's see what shape it's in. It probably is going to be in a very bad shape, but it's actually not bad. I'm going to examine it. This wire is so tiny, I'll actually need to examine it under the microscope, just to make sure that there is no damage on the wire, so that we are not going to get shorts as we plug it in. Okay, so this is our wire. Looks like we have, except for the red one, everything else looks really good. But the red one has a little bit of damage. Yeah, there is definitely damage to the red wire, because every thread that's sticking out like this is potentially exposing other threads to this 12 volt power, and that's what kills the CAN transceiver, and for that matter, the rest of the electronics. So we're going to clean up this wire and see if we can make it look nice again. So first things first, need to cut it. While I'm at it, I'll make a loop like this so that we have it securely inside of the enclosure. Now, the only way I find that's reasonable to trim such a wire is to use this sort of special tooling. All right, now we have all the wires exposed. Let's get again under the microscope and separate them. Okay, then need to separate blue and green. Looks like there is a blue green thread that's going around There you go. Okay, let's twist blue and green separately. Next, I will disconnect the test wiring. And let's reattach the original wire. For this, we're going to need some more flux, and for that matter, a little bit more solder. Looking real good. All right, so we're going to start left to right. Blue wire goes on the left, and that's ground. Green wire is next, and this is data for CAN bus. Gold wire is next, and that's the data for CAN bus as well, the other part. And finally, the red wire is the power, or the VCC. Okay. I will seal this loose wires as well, because I'm not too happy that I still have things sticking out. But for now, we can test. Well, actually, let's clean up a little. Okay. I'm going to use my multimeter to first make sure that there are no shorts on the USB to the wires, because such tiny wires can cause issues. Ground, no, nothing. This is power, and nothing, nothing, nothing. This is one data pin. Okay, I don't see any shorts on the wiring, so that's all good. Okay, let's test. The screen is on. I can kind of see it a little bit. And it gets recognized. Okay, and you can see that the screen actually works. Communicates with Apex, and it's working again. Okay, so what I'm going to do is I'm going to clean up everything here. I'm going to also seal the wiring here with some liquid tape so that nothing gets shorted. And that will complete the repair. All right, so we just repaired an Apex display that had a blown resistor. It looks like it blew perhaps because of a short between the ground and the power on AquaBus. Maybe not, I don't know, but definitely gone. You had to replace it. The replacement worked. The screen is operational, the buttons work, and it communicates with Apex head unit. Well, if you enjoyed this video, please like and subscribe, and I will see you next time.